Hey everyone, today we're gonna be doing a Leetcode question which is rainwater trapping problem. So this is a very famous problem which is rainwater trapping or how much water you can collect in some container or bucket something. So we are given some integer array which is the height of the you can say a building or you can say the elevation map. So they are saying like how much water can be trapped between those buildings. So if you see this black bars are the building, and you can see this blue color is a water is allocated in between them. So we just need to find like how much water can be trapped in between, and each building or can say each trap you can say it is one bar equals to 1 unit. So every building or bar is elevated as a 1 unit of height or the ratings. Similarly, they are given the constant like the height of the, you can say height or the length can go from 1 to 10 to the power 4, the element inside it and the height of it. So height can go from 0 to 10 to the power 5. So it can be minimum 0, maximum 10 to the power 5, as it can be the height of a bar or building, you can say anything. So let's see how this question we can do with some example. So I'll open my notes. So let me write down some of the examples. So we'll take first example itself. So what we are given, uh, okay. So we are given some height input. So I'll say, okay, height is given. Um, there is a height array 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2 and 1. So we are given something like this array. We need the output. So output in this case is you can say 6. Okay, so this is given in the question like this is an input and this is input. We need the output as a 6 over there. So what we can do, uh, let's see what is this question exactly is asking for us. So we can say, okay, this is something given in a grid or there is some map of a building. If I say, okay, something is like I have as my building. So what I can do, I'll say, okay, this is my building layout. Just 1 second. Okay, so this is my building layout. I'll say, okay, this is my building, and I can say I will be having some bars. So bar will be like you can say if I say I have initially 0, so I have my bar as a 0 first. I'll say okay, 0 will be here. This is my first building. Okay, second building having the height as 1. Okay, next building height as 0. Another building has height 2, then 1, then 0, then again 1, then 3, then 2, then 1, then 2, and then at last 1. So I'll say, okay, this will be my some height. So initially I don't have any height. I'll say, okay, I don't have any height. I'll mark this as a bar. Another one, I have a height like 1. Another I have 0 height. The next one I have height equals to 2. Okay. The next one I have height as a 1. So I'll say, okay, this is my height. This is my height. Another height is 0. Next height is also 1. What I am doing like I'm saying this is my something height of a building. Again I have one building having height equals to 3. Okay, I have one more building which is having height equals to 2. My next building height is 1. Another building height is 2. And the last building height is 1. So I'm given how many buildings? If I say, if I mark this 0, 1, 2, 3, 4, 5, 6, so let me mark this. So I'll say, okay, if I mark this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total I have 12 buildings. I'll mark the height, I'll mark the indexes as well here. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So I have total how many buildings? Total I have 12 buildings. Okay. And these are some height of the building. What is the like what we say in the question they're asking how much water can be trapped between these empty spaces. So if you see, if I start from here, I don't have any stopping point here, so my water will be fallen out from this position. Okay. Similarly, if I say, if I stand over this place, I don't have any stopper here, so my water will be falling out from this place. So if you see, if I say any of two building which is having some height, so you can say the height, or you can say water will be like placed in this empty space. Similarly, it can be placed over here. Similarly, it can be placed over here, but it can be placed over here also. Okay. So we just need to find like some position, or you can say some stopper. So you can say, if I say in this 2 point, my water can be allocated like this much. How much water? This much water. After this, it will be fallen out. For this case, I'll say, okay, my water can be stored like this much. After this, it will be fallen out. For this particular case also, my water will be stored like this much. After this, it will be fallen out. If I say for this case, okay, for this case, my water will be stored like this much in every spaces. If you see, if I store my water here, if it will be fallen out, it will be storing here as well. So it is not wasted. So I'm just storing my water in this empty space. Here also, the one amount of water will be stored, and another it will be fallen out. So if you see how much water I am just allocating, so initially like for this bar, I'll say, okay, this much I can have. For this I can have this much. 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 So this is my water allocated in between. Okay. So let me draw. So how much water? I have this much water in the first bar. I have this much water in my second bar. Not a bar, you can say these are some building. I'll say, what is this? This is some building. This is some height of a building, and I'm saying like my water can be located in some places over the building. Like in between, there are some empty spaces. I just need to tell how much water can be allocated between two buildings or between multiple buildings. So I'll say, okay, between these two buildings, this much water can be allocated. Between these three building or two building, I'll say, okay, this much water can be allocated. For this, it is like this much water can be allocated. And for this, we have already marked like this much water can be allocated. So if you see, they've asked how much water will be allocated here. So let me see. Um, okay. So if I mark over here, like I have this height as 1. Okay. I have this height 1, 2, I mean. So what I'm saying, if I say I have stored one unit here, I stored how much unit? If I say this is some boundary, okay, this is one boundary. My boundary is like this, or let me take some bold. Okay, I'll say okay. This is my boundary one. Another boundary I have this much. Okay, another boundary I have this much. For now, it is having only how much? 3 units. Like from 0 to 3 I have values. So I'll say okay. Initially I have taken 1 unit from this particular case. I have taken 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, 1 unit. Total how many? 3 units. So I'll say okay, 3 unit came from here. I'll say 3 came from here, or you can say 2 came from, if I say I have taken 2 from here, I have taken 2 from here, I have taken 2 from here. If you see, I am taking how much? 2 to, you can say water can be stored, you can say like there's some spaces, how much height is there. So what I'm saying, the water inside this area can be stored. So let me take the exact values now. So I was just explaining how we'll be doing this. So what I need to do, if I say, okay, this is some bar I have, what I'm saying like, I have some bar like this, okay. What I need to do, I need to store some of the height. So initially there was some empty height, I have this much, okay. The next height was 1. If you see here, I'm just marking again this one. So if you see my 0 height I have marked, I have 1 height I marked, I have 0 height, I'll again mark. I'll say okay, this is my again next height. My next height is 2. I'll mark it again 2. Next height is you can say 1. Okay, I have the next height. I'm just marking it again because I just wanted to tell one more thing, how we gonna be approaching this one. So I have some spaces, again I have 1, again I have something like 3 units, I have then again 2 units, okay, I have again 1 units, I again have 2 units, and I have 1 unit. So I'll write that down also. So I'll say here I have 0 unit. Let me mark it more clear. So let me take a white color. Okay. So I have initially 0 unit. For this I have 1 unit. For this I have 0. For this I have 2. For this I have 1. For this I have 0, 1, 3, 2, 1, 2, and 1. Okay, these many units. You can say this is the height of some building. Okay, so this is height of some building. I have given the height like this. So if you see now, I have this height. Okay, I have this height, and these heights are like attached between them. Let me mark it more broader. So just 1 second. Mm, let me take one more. So this is some height. I have marked it 1. So if you say, I don't have any spaces here, these are the buildings. If you say, this is my empty spaces including this. So for now here, there can be like how much water here? This amount of water and this amount of water. So initially like I have drawn which is like including the spaces as well. So it is not spaces like these buildings are joined in such a way like you will be allocating some, I can say I will mark again some more dark, like I have this as a building, this complete as a building, okay. I have this complete as a building. I have this complete as a building. Again, I have this as a building. I'll say okay, this is my building. Again, this is my building. So what I'm saying, I don't have any spaces here. So if you see here, I had just a top of a building. I have this top, 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 this top, this top. So if you say water can be stored over this position, this much over here, and this much. So if you see, if I count, there can be 1 unit, there can be 1 unit, there can be 1 unit, 1 unit, 1 unit, total like 4 units, 5 units, and one more 6 unit. So if you see, the output is 6 unit. How can we do this? So what we need to do, we need to find like what will be the you can say the maximum value. Like if you want to see, if I place my water over here, if I say I store my water 1 unit here, if I again put some water, it will be going out of this building. So what I need to do, I just need to fill out the water, how much, till the maximum height of the last building. So if I say this is my boundary condition, this is my boundary condition, I cannot fill more water than this much. So for this, the boundary condition is this and this. If I say for this building, boundary is this and this. So for this building, it cannot store water. For this building, water can be like maximum bar is this, maximum bar is this. So this is my boundary condition. Water can be stored is this 1 unit. Okay, this is 1 unit, this is 2 units. So water can be stored how much? 1 unit. For this case, for 0, my maximum is like the maximum boundary for both sides is like 2 and 3. So water can be stored like this much. So 1 unit here, 1 unit here, 1 unit here, 1 unit here. So how much? I am saying just I have some boundary condition for all of them. So for that I need to find the right and left maximum. So like For this, it cannot go beyond the maximum boundary after, see, if I take something lower than this, if this is the better example, if I say I'll take something lower than this, it will be like going out of the, you can say, a building. My water stored here will be flowing out if I take some boundary less than this height. So if I mark, I'll say, okay, I can store the water till the maximum height, either left or like both the side. It should be some boundary so that water can be stored in between. So for this maximum boundary and this maximum boundary, water can be stored in this much area. Okay. So what is my approach is now? So I'll say my brute force approach is for every position, I'll find the right maximum and left maximum. So if you see for this 0, I'll say my 0, if I say for this particular, my left maximum and right maximum both is 0. For this particular case, if I say, okay, for this particular case, my left minimum is 0, my right maximum is 1 itself. So if you see, or let me say, for this 0, left maximum was 1. So I'll say, okay, for this particular case, my the left maximum was 0, right maximum was 1, because this was the boundary for this. Like it can go till this. It cannot flow over this, but it can go at max here. But the left boundary is 0, so water will be flowing out here. Okay. So similarly, if I say I have for this particular case, for the 1, I'll say my left minimum, you can say left maximum, 1 itself, right maximum will be 2. And for 0 case, I'll say for this one, my left maximum can go for 1, maximum, like right maximum can go for 2. For 2, I'll say left maximum is what? 2 itself, because nothing is less bigger than this, so water cannot go beyond this condition. I'll say okay. And my right maximum is 3 because it is going till this boundary. So for this particular case, for this I have left maximum as 2 and for right maximum it is having 3. For this particular case, my left maximum is 2, right maximum is 3. For this one also I have left maximum as 2, right maximum is 3. Okay. For this particular case, like 3, my left maximum and right maximum both are 3. Like it cannot fill the water anywhere, because after this, if I fill some water over the top of this building 3, having height 3, if I put any water, it will be flowing out because nothing is more than this height. So if I place some water, it will be going out of the building. For this particular building, if I say what was our building size is there, like this is 2. Okay, let me see. This was 2, this was 1, and this was 2, and this was 1. Okay. So for this, I'll say I have marked like I have for this one. For 1, I have maximum 2. For this, I have left and right maximum 3. For this, I have left maximum as 3. Okay. I'll say for this, I have left maximum. Sorry. So where is my pointer here? So I'll say for this particular 2, I have left maximum as 3, right maximum as 2 itself. For this one, I have left maximum as 3, right maximum as 2. Okay. So for this, you can say it can go maximum this much and maximum this much. Okay. For this 2, I'll say it can go maximum, like right maximum go till 3, but left can go to 2 itself. I'll say okay. Now, if you see for this one, it can go maximum to 2, 3, but minimum it can go to the border itself. So you can say if I have some boundary, it cannot go beyond it. Okay, I'll say fine. So what I am saying, for this, I have my left boundary as 3 and right boundary as 1 itself. So if you see here, what I'm saying, this is telling me how much water can be stored using this boundary. You can say, okay, it can store the minimum water in this area, like the minimum boundary will be having the water. If you see, maximum is this, minimum is this, water can be 0. For this, water can be 1, 1. For this, water can be like going till this boundary to this boundary, but at max water can go till this boundary. So I'll take the minimum of both them, because water can go at max to some boundary. Okay, I'll say fine. So what I'm saying, for each phase, I'll say okay, find me the left and right maximum so that I can store some water till my height. Okay, for this height, some water will be there. For this height, water will be there. For this particular case, water will be there. So for each height, I'm saying I will be storing some water. Okay, how much water? The height, the minimum of them height minus my height. If I say how much water can be stored here, the left height and the right height, I'll take the minimum. I'll say, okay, remove my height. So this much water, like 1 unit water can be stored between this building. Or if you say between this building, I have 1 unit. So my brute force approach is like for every particular position, find the left and right maximum. For every building, I'll find the left and right maximum. So if I say for every number, you can say for every building, I'll say okay, for every building, I can say for each building, I find, uh, I'll say okay, find left and right maximum. Okay. So after finding this, I'll say okay, left maximum minus my current element. I'll say the element itself, and I'll take the minimum of both of them. So I'll say okay, right maximum minus the element. So whichever is lowest, I'll say okay, this is my left minimum, this is my right minimum. Sorry, maximum. This is some boundary condition. I'm saying how much water can be stored here. I'll say for this left maximum is 1. For this particular case, like if I say this building having height 1, my left boundary is 1, right boundary is 2. I'll say okay, whichever, like left boundary minus this element, right boundary minus this element, whichever is giving me the minimum value will be having my water stored in it. I'll say okay, this is my water. So for each number, I'll ask the left and right maximum. Then I'll check whichever is giving me the least value, I will be like appending in my answer. So if you see for each building, I'm checking left and right. In that case, like my TC, I'll say my time complexity will be n square, because for each for each building, I'm checking my left and right building, like the maximum building to this. What we can do, in order to avoid this one, we can store this in a, you can say, array. Like we can store our left and right maximum. So this is what we have done. Like we have stored our left and right maximum. If you see, for every window, like every building, I have stored some value. I was checking like whatever the right and left maximum. I'm just saying, okay, how much maximum is there till this point? I'll say 0 for this 1, then 2, 2, 2, 2, 3, 3, 3, 3. So I'm saying at this point, what is the maximum value you have found till so far? I'll say 0 for this 1, then 2, 2, 2, 2, then 3, 3, 3, 3. So I'm saying till this point, how much maximum value you have stored so far. So this is my sum array. I have stored this in some array. I'll say this is my array. I'll say this is my left max array, this is my right max array. So this is some array. We have done some pre-computation. We have done this, like we have stored this in order of n using the iteration also order of n. Okay. So we have stored this in some iteration. We have done the prefix sum, or you can say suffix sum, or you can say we have stored the left max and right max so far in this array. So we have iterated and we have just stored the element max so far. So for this we have used order of n for storing and iteration. Then again we'll iterate over this array. I'll say okay, for this number 0, 1, 0, 1, this is our array. This was our array. I'll say okay, take minimum of this, like okay, left max minus the element and right max minus the element, take the minimum of both of them. So whichever is giving me the minimum result, I'll store in that my answer. So for this, if I say for 0, 0 minus something something 0, it will be giving me 0. For this I'll say okay, 1. Okay, I'll say 1 minus 1 and 2 minus 1, the minimum is 0. So I'll say this particular boundary is giving me 0 value. For this, I'll say okay. 1 minus 0, 2 minus 0. Minimum is 1. So for this, I have stored 1 unit of water. Similarly, like this was our first approach. I'll say answer equals to like plus equals to, I'll say the minimum of this one. Okay, I'll say minimum of any of them. In the next way, I'll do the same, but I'm not find the left minimum and maximum. What I'll say, okay, for each building, okay, for each building, just I'm iterating. I'll say for I have something like for I in range, or you can say for I in size something, I have this building. I'll say, okay, finally, I'll say, okay, answer plus equals to what? Minimum of the left max of I minus the area of I, okay, comma, I'll say right max of I minus element of I. So whichever is giving me the minimum, I'll store at my answer. So this is what this is. Left max means I have stored my left max in such a way like I am just storing how much maximum you have got till so far. So I'll say, okay, 0, 1, 1, 1, 2, 2, 2, 2. So I'm just storing all my left maximum from left to right, and similarly for right I'm storing from back. So I'll say from back it will be storing some of the element. So if I say, if I create my left and right maximum, this is my left maximum, this is my right maximum. So for here, if I say starting from this particular case, I'll say, okay, it will be giving me 0, 1, then 1, then 2, 2, 2, 2, 3, 3, 3, 3, and 3. So I have stored my left maximum, like how much so far I got here. Okay, so I'll say tail it 0. I got 1, so left max again 1. Then I got 0, so it will be again 0. I'll got 2. Okay, fine. I got 1, then 2, then 2, then 2. I got 3 now, so my left may become 3. So I stored my left maximum. Right maximum, similarly, I storing from right. So I'll say, okay, my right maximum is 1, then 2, then again 2, then again 2, then 3, 3, 3, 3, 3, 3, 3, and 3. So this is my left maximum, this is my right maximum. I'm just storing from left to right. And for this, I'm storing from right to left. Okay, so I'm just storing my maximum so far, starting from left to right and right to left. For each, I'm saying, okay, now I will iterate over this array again. I'll say left max minus the element and right max minus the element. Whichever is giving me the smallest amount, I'll just store it my to the answer. Similarly, for this, our time complexity is order of n and the space is also order of n. But now we need to optimize a bit more. So I'll use third approach where we will be ignoring this part, like I will do in the constant space. If you see, like we have just storing all the result in the increasing order, and like just we are iterating from left to right and right to left, we are just checking the values. So for this, I just store 0, then I stored 1, then I again check the previous. It will be checking like array of I minus, or you can say array of I comma array of I minus 1. So we are checking last two occurrences like this and this and this and this. So whichever is the maximum, I am just carrying forward. So instead of storing this in the result, I can just take the value itself. Instead of array, I just take the number, the element itself. So what I'm saying, I'll say, okay, I got my left max as this, then I got this. So instead of creating whole array, I can just store my value in some number. So I will be iterating from two pointer. You can say two area. You can say two points. So I'm just starting from two pointer. Like left will be here, right will be here. So I'll say my left is here, right is here. I'll say, okay, I have some value, I have some value. Store this as a left maximum and this as a right maximum. Iterate, just check whether this is giving me the left maximum more than this one or it is giving me less than this one. So I'm just like iterating from left to right. I will be just iterating, this will be left, this will be right. I am just going one by one. Whichever is lowest, it will be going the next because I need to find minimum from both the side. So let me give you some like code example how we gonna be doing this so that you can get it easily. So I will be storing some of the left and right pointers. So I'll start my left from 0. I'll say okay, left start from 0, right start from size minus 1. Okay, size minus 1. So size is, I just need to calculate the size as well. So okay, size is length of height. So we are given some height array. Okay, this is some height array. I have my size. Then I just need to like store some result. I have my left maximum and right maximum. I have some max left and max right. All are 0, 0, 0 for now because I don't got any answer. I have everything less than that. Now I'll just iterate from left to right. I'll say okay, left, like I will say I'll start from both the end and I'll say okay, when I'll just iterate till they are not meeting, my left and right are not meeting themselves. I'll just say okay, I'll use the two pointer approach. I'll just start from left, I'll iterate to like minimum, or you can say mid of them, minimum like mid of left and right. So I'll say okay, now if you see, if I'm starting from left and right, I need to like store the minimum of them. So I'll check if my height of left and right pointer, whichever is minimum, I'll go with that. I'll say if height of a left pointer is greater than equals to my right pointer, so I'll say height height of my right pointer. So if it is a case, means my left value is smaller, I can increase my window size. Like it can be a potential answer. The water will be flowing over it. So I just need to increase my window size. I need the how much water I can store. So I just need to remove all the smaller window first. So I'll say if my left window is like my left building is smaller, I'll say okay, left I just need to shift to some more bigger size window or building. So I'll say, okay, if this is the case, just go to left case. I'll say, okay, left plus equals to 1. Else, else means my right window is smaller. I'll say, okay, right, just decrement one of your window size, like reduce your size, or like come to the next window from right. Now, for each window, I'll say, I just need to store my, like I just check my left max so far. So I'll say left max will be left max, um, max left, and like how much can be my next left. I'll say okay, height of the uh, height the height array. I'll say height array of the left, the current element. I'll say what is the maximum of both of them, the current one and the max so far. So I'll take the maximum of both of them. After this I just need to calculate my result. I'll say okay, whatever is the maximum, just subtract from the array. So I'll say okay, max left minus height of, I'll say height of the left pointer, because this is my potential, like you can say the current position. Similarly, I'll say okay, use the same approach, okay, use this same method, but instead of left, I just need to find all the right. I'll say okay, for left, I just need to have the right. So I'll say this is my left, I'll say okay, just get the right. So okay, this is my answer. I'll say okay, now just return the result at last. I'll say okay, return result. So let me compile this code. Let me see if it is working fine or not. So it is running. So it is giving me right is not defined. So what we have done, okay, we have this as a small right. And similarly for this, I'll compile this one. So okay, it is giving me the incorrect value because what we have done, I was just storing my the maximum of both of them and write max in the right pointer. I will be iterating over this array. I will be storing my left max. Okay, I just need to store the left max instead of right max. So I just gave the opposite. Let me compile it again. I'm just storing my right maximum over here. So this is running fine. I just need to submit it and let's see if it is working fine or not. So yeah, this is worked, and you can see this code is like best code, you can say. It's the most optimized code, and we have done a linear time complexity and a constant space. So that's all for today's. Thanks for watching.